Good evening, everybody. Welcome to week 3 of Lambda School's Mini Bootcamp. My name is Deandra Ryan Moss, and I'm your instructor. So for anyone who is joining us for the first time, I'd like to introduce a little bit about Lambda School and about this bootcamp. So let me tell you a bit about Lambda School. Lambda School is a computer science and web development immersive. So it is a 6-month full-time program in which we get you as a beginner developer, ready to work in the industry. So we are going to teach you everything from the ground up. So our topics include mostly web development topics. So everything that you've seen in this bootcamp of front-end development, so HTML, CSS, JavaScript, we all go into in great detail in the main curriculum. We also dive a lot deeper into JavaScript and see a number of frameworks, such as the front-end framework of React or the back-end framework of Node. But beyond web development, we also try to cover computer science. So beyond just JavaScript, we look at 2 other languages, Python and C, both of which are extremely versatile languages if you're looking to do object-oriented programming or data analysis. So by the end of the course, not only are you a fully competent web developer, you also have this computer science background that a lot of web development bootcamps don't offer. So Lambda School is pretty great in that we teach you a ton of stuff in 6 months' time. And so let me tell you a little bit about our tuition model, which is something else that I think makes Lambda School really unique. So while you can pay tuition up front if you want, we also offer a program where you can not pay anything up front and actually pay us back once you are hired. So we only get paid if you get a job as a web developer making $50K or more. So once you have that job, you can pay us back your tuition over the first 1 or 2 years you work. And in that way, there's no risk. If you don't get the job that you came to Lambda School for, then we do not get paid and you don't have to pay us. And the reason we do that is because we're very confident in our ability to bring in great, competent people and to get you out into the world with our hiring team and get you hired. So that's a little bit about Lambda School. It's a 6-month full-time program, and we also do offer a year-long evening program for people who want to continue to work. So if you're interested in that, reach out to our admissions team. We do prioritize people who take the mini bootcamp, so definitely reach out about that. And on the subject of the mini bootcamp, if you are new to this, what the mini bootcamp is it's a 3-week course where we teach you just the fundamentals. So it's for complete beginners, and we're going to teach you just scratch the surface of what you would see in the main curriculum. And if you are new to this web series, I will say that we're in week 3, and if you're a beginning programmer, it might be a little difficult to jump in. So I'd recommend going and checking out all the videos that we have posted online, or go ahead and join us next month for the next iteration of the bootcamp. So let's go ahead and talk about what we're going to explore tonight. And before we get into the material for tonight, I do just want to say one thing to everyone who's been with us, which is that week 3 is definitely the deepest dive. We're seeing the most complex topics. And I really want to clarify that what we're introducing you to this week is not something that you can master this week. If you somehow are able to master this, then you are a programming wizard, and good for you. You're probably going to end up running a company in Silicon Valley, but not all of us are there. And I know that for me, these topics took 6 months of working with before I really felt like I totally got it. So the point of what we're doing this week is introducing you to these ideas that you will get a more full understanding of in the main curriculum. So if it doesn't 100% click, that's totally normal. We just want to get your feet wet. So on that note, I want to introduce the idea of callbacks, which is what we're going to be exploring tonight. So we saw a lot of really neat stuff last week. We spent the entire week on JavaScript, and I think you guys are starting to get a sense for just how deep the JavaScript rabbit hole goes. And we are going even deeper this week. So callback functions are a very huge part of what makes JavaScript, especially backend JavaScript, so powerful. So I'm excited to teach it with you guys. I'm going to go ahead and share my screen so we can start doing some actual coding. Okay, so let's talk about callback functions. In order to wrap your head around callback functions and get an idea of how they work and how to use them, it's really important to make sure that you've mastered the idea of functions in general. So I introduced you to functions actually 2 weeks ago, and then we've been seeing them in a few different forms over the course of last week, but I'm just going to go ahead and start with a total review of what functions are. So for starters, let's just talk about declaring functions. So when you declare, there are 2 different ways to declare a function. So let's go ahead and create a function that just takes in a number and returns that number plus 2. So we'll call it add2. It's going to take in one number and we'll return that number plus 2. This is a pretty simple function, but there's still a lot going on here. So I want to take some time to explore it. First of all, we'll look at the way that I declared it. So this is one of 2 declaration styles. What we've done is we've actually created this function over here, an unnamed, on the right hand of the equal sign, we've created an unnamed function or an anonymous function, which we'll see a lot more of. And then using that standard variable assignment syntax, we've saved that into a variable called add2. And so that is one way to declare a function. Another way is we just use the function keyword, we name it, and then everything else looks the same. So as I mentioned when we first looked at functions, these declaration styles are really similar. There are some subtle differences, such as that this style is actually hoisted, which means we can call it above where we actually declare it, which wouldn't be allowed here. But the important takeaway for these 2 declaration styles is this idea of that we're taking an anonymous function over here and saving it into a variable using that variable declaration syntax that we see with any other data type. So I'm going to focus on this declaration style because this idea of anonymous functions and saving them into variables is going to continue to be really important as we go on tonight. So beyond the syntax of declaration, let's talk about what else is going on here. The two of the most key things that need to be thought of when declaring functions or using functions are the input and the output. In other words, the parameters and the return value. So we know that our parameters go up here in the parentheses. In this case, there is only one parameter, a single number that is being passed into the function. Then generally we manipulate that value in some way inside of the function and then return something else. In this case, I've stored everything on one line in that we're manipulating right here. We're adding 2 to that input number. And then we use the return keyword to say, okay, the output is going to be this value. So if I call add2 over here, I pass in a 3. And then my output, my return value is 5. And as a little reminder, we always know what our return value is in Replit because it appears in green over here. That tells us that this function resolves to the number 5, or in other words, it has a return value of the number 5. If we're not in Replit, another way to tell is we can always store something in another variable. So we could return value, and then if we want to see what return value is, we see that it's defined. And not every function has a return value. In fact, if we got rid of that return statement, now the return value is undefined. So from the perspective of writing functions, we can always tell what the output or the return value is because of the return keyword. If we're actually using the function, calling the function, then we can tell the return value because either if we're in Replit, we can just see it appear in green, or we could assign the function to a new variable. And if that variable is defined, then we have a return value. So this is just kind of a simple example of a function. There's one more thing that I want to explore before we move on. And one more thing I want to review, that is. And that is the idea of a function versus a function call. So this variable that I've created here called add2 is a function. So if I went ahead and ran this, we see that add2 is actually a function. This variable name refers to this logic. So we can think of a function as being the potential for something to happen. But when we just have the variable name by itself, the function has not been run yet. Nothing has happened. It's just potential. So that is a function. And we want to be able to distinguish that from a function call. So if I do add2 with parentheses and then pass in my value, now we have a function call. So this whole line of code resolves to a number. This is not a function. A function is run in the course of this executing, but the final result is not a function. It's actually a number because this function outputs a number. So whereas this bit of code resolves to a function, this bit of code is a function call, which resolves as a number. And some functions resolve as numbers, some as strings, etc. But in this example, the important thing is to distinguish the difference between the function itself and the function call. And the easiest way to do that is the parentheses. If we have parentheses, we're looking at a function call. If we just have a variable name, we're looking at the function itself. So distinguishing these two things is going to become really important tonight. So hopefully I haven't spent too much time hammering that in. Okay, so now that we've reviewed a few things that we know about functions, I want to introduce a couple things that you might not know about functions. The first is that JavaScript is really cool in the way that it approaches functions, in that functions are essentially treated like any other variable. And we can already see that a little bit with just the syntax, because I've created this function over here, and then I just save it into a variable, exactly the same as if I were creating a string or a number or an array. So another thing we can do that's kind of neat about functions is that we can actually pass them around into different variables. So if I created another variable called, spell increment wrong, increment by 2, which is not quite as neat of a name, I could actually save the value of this variable into another variable. So in that way, I could call this using increment by 2 or add 2. The point being that we can just pass around functions in any other way, just like we can pass around any other variable. Generally speaking, we don't need 2 copies of the same function, but I wanted to show you this just to demonstrate that functions really act in JavaScript like any other variable. And so that brings us to our next crazy thing that we can do with functions, which is that we can actually pass functions into other functions. So now we're getting into some really meta territory, but this point is extremely fundamental to what we're seeing tonight. So let's say that I had a function called, let's see, we'll call it add2 and log, which is kind of a wordy function name, but oh well. So what we want this to do is take in a number, and we want this thing to add 2 to that number and then log the result. Now, to be fair, we could really simply just write this as number plus 2, right? That would admittedly be the simplest way to write this function. So we take in the number, we add 2, and then we console log it. And when I run it, I see that 11 has appeared in white on the console over here. And notice that in green, we have undefined because this function has no return value. There's no return statement down here. So yes, we could do it this way, but I'm going to show you one other way we can do it, just to illustrate my point. So I could also have a function here. So I'm going to call it fn for function. And instead of adding 2, let's do this. Let's do, we're going to call our function, pass in the number, and then we're going to save the result. So let's take a look at what this line is doing. We're actually calling the function that we pass in. So this function is actually a parameter. It's coming in from the outside. We pass in the number, we save the result, and then we are going to log the result. And so now this thing takes in 2 arguments, right? We have a number, we have 9 as our first argument, and then I'm going to do add 2 as my second argument. And notice that it works exactly the same. So I wouldn't worry too much about what's actually going on inside of this function, because this is the meat of what we're going to learn tonight, and you will see a lot more examples of this as we go along. But the takeaway I want here is that this function is being passed in as an argument. So just like we can create functions and save them into variables, we can reassign functions into new variables, we can also pass them in as parameters. So this is pretty meta, right? Because we have this function that we're writing, but then this function takes in another function. And that is what a callback is. A callback is a function that we pass into a function. So once again, the takeaway right now is just that functions in JavaScript work like any other variable. Yes, we can just declare them and use them, but if we want to do stuff that's more complex, like pass them around, pass them in and out of functions, that's totally allowed too. And that's exactly what we're going to explore tonight. So let me go ahead and get rid of all this and break down another example for you. Actually, before I do that, I want to just talk a little bit about what callbacks are in general. So let me bring this back. So I said that this here is a callback function. And let me define that term, callback function, because that's what we're learning about tonight. So a callback function is literally just a function that is passed into another function. So whenever you have a function as an argument or as a parameter for another function, then it's called a callback. This thing would be called a higher order function. So we're going to come back to this differentiation between a callback function and a higher order function all throughout the night, because it's really important to keep straight which is which. So the higher order function is the function that takes in another function. So this is like the higher level one. This one has the parameter that is the function. Callback, the callback is the one that's actually being passed in. So in this case, add2 and log is the higher order function. Add2 is the callback function. So why would we do this? It is kind of neat, and it is a little mind-boggling, but whenever we're learning something, we want to know what's the point, right? So before we actually look at some more examples, let me just start to talk about, in general, why we would do this. So the first reason we would do this is this principle of dry programming. Don't repeat yourself. And I've talked about this a lot the last 2 nights, the last 2 nights of last week, in trying to show you some examples with classes and prototypes, because we always want to, whenever we're writing code that's repetitive, we always want to find a better way to do this. And as you'll see in some examples later on in the night, this technique of being able to use a callback function allows us more versatility. It allows us to write neater, drier code, and that's always a good thing. The next big use case for callback functions is asynchronous programming. So we will not actually see any examples of asynchronous programming in this boot camp. It's a really big back-end JavaScript topic that will absolutely be covered in the main curriculum, but it's a little outside of our scope. But I just wanted to mention it as a use case. So whenever we're doing back-end JavaScript programming, we code in a style called asynchronous programming. And essentially what that does is it allows our code to run really efficiently, which is super important because in web development, we're always worried about a user. So we have to make sure that our database is responding as quickly as possible so that the user on the other end isn't left waiting. So in asynchronous programming, it turns out that callbacks are pretty key. So it's really important to know this topic as a web developer because it's absolutely critical to learning how to do back-end programming and even some asynchronous front-end programming. So the final use case for this is there's a style of programming called functional programming, in which case essentially everything is a function. Once again, this isn't something we're going to get into in this boot camp, but I just wanted to make you aware so that if you hear the phrase functional programming and you're curious about getting into that, you'll definitely want to know how to use callbacks really thoroughly, because callbacks become really important in that style of programming. So that's a little explanation of why we're doing that. Let me go ahead and move on so that we can see some examples of when we use this and why this is really awesome. So we're going to cover kind of two different facets of using callbacks tonight. The first thing we're going to look at is actually how do we use higher order functions. So as a reminder, higher order functions are functions that take in functions as parameters. So first, we're going to be looking at using higher order functions. So there are some higher order functions that are already built into JavaScript for us, and we want to be able to use them. So first, we'll look at that. And then in the second half of class, we're going to go ahead and look at how to write our own higher order functions. So you got a little sneak peek into that in the example I just showed, but we will deep dive into that a little later tonight. So the best example of higher order functions in JavaScript, or at least the most common one that I find myself using, are array methods. So let me go ahead and create an array for us. I'm just going to create an array of numbers. So we have, okay, here we go. So here's just an array of some random numbers. And the first thing I want to show you is something called a for each loop. So as we know, we are totally welcome to loop through this thing using our friend the for loop. And if we wanted to say console log everything in the array, we could use this bit of code. So let me run it. We've logged everything in there. So as a reminder, we're looping through from index 0 to up through the array's length. And then at each index, we're going to console log the array at that index. And I've used bracket notation, which we learned last week, to look it up. So for loops are not bad ways to go, but to be honest, that's not really how we like to loop through arrays in the real world of programming. There's a much more sleek way to do it. And it's an array method called array.forEach. So every single array has this .forEach method on it. And it's a way of looping through arrays. So as we know, a method is just a function, which means that methods can also be higher order functions. So this thing is going to take in a callback here. So we have to actually create our callback, right? So our callback will be a function as well. All right, so let's talk about what's happening here. Down here, we're going to loop through our array. We always use this array.forEach syntax, and then the forEach method takes in one argument, which is a function, a callback function. So I want to break that down and be really clear about that, because it's super easy to get confused about, are we talking about our callback or our higher order function? So for our higher order function, we have forEach, which is a method that arrays have. So this thing has a one parameter, which is a callback function. It also has, I will just say, no return value. Cool, so this is our higher order function. Now we have to look at our callback function. So over here we have callback function. And we've just called it callback, which is a very simple name. So this thing also has one parameter. It's going to be an array item. And it will have no return value. So for every single function that we put into forEach, it always, technically there are actually more than one parameters that we can use, but we're just gonna look at the first parameter tonight. So if you learn more about forEach later and you're like, hey, she said there's just one parameter, I will say right now, okay, I'm slightly lying to you about that. But for simplicity's sake, let's pretend there's just one parameter, an array item, and no return value. So every time we put a callback function into for each, it has to look like this. There has to be just one item, which is the array item, or one parameter, the array item, and then no return value. So we're going to somehow manipulate this array item without returning it. And a really easy example of that is console log. So think about this callback as being, what do we want to do in our loop? So what do we want to do to each item? And in this case, I just want to console log each item. So, so all we have to do is write a callback function in which the logic of what we do to each item exists, and then we put that callback function into for each. So let me go ahead and run this. And notice it ran exactly the same as our for loop. So it's there. This looks like a lot of code because I've commented it pretty detailed, but this is actually way simpler and way more elegant than that for loop. And we really like using for each loops. So I would recommend practicing with these. And from here on out, if you're ever looping through an array, use a for each loop. So this was a really simple example, but let's say we wanted to slightly manipulate it. So instead of just logging the array item, let's say we want to log the negative version. So we first want to log -1, then -5, etc., ending with +2. So over here, we're console logging the negative version of each array item. And looks like that one worked out too. So I want to show you one more way of doing the same thing, which is that over here, I have created my function. I've saved it in a variable called callback, and I've passed it down here. And that's totally valid. And I actually personally really like the syntax style because I think it's very readable. But you'll also commonly see something else, which is that we can just put the anonymous function straight in here. So all I've done is instead of passing in, let me get rid of that. I don't want that. So instead of passing in a variable name that refers to the function, I've passed in the anonymous function itself. So we can go ahead and just write our callback functions directly in the method. And the syntax, I remember when I first learned it, the syntax was a little intimidating, but you get used to it, I promise. So if we run this, it works exactly the same. Let's say we wanted the array item +10. Whatever we want to do to this array item, we just change it in the callback function. And then for each, we'll do its little magic and everything will be logged. So one final thing I want to mention here is that we are passing in a function. So we want to pass in just the function name. We wouldn't ever want to put these parentheses after it because then we're passing in a function call. And that's not right. We want to pass in the function itself. For each will call this for us, kind of out of sight, out of mind, but we don't need to actually call the callback ourselves. That will happen behind the scenes. So that is for each. I want to show you another array method called map. And so map is definitely related to for each, but maybe a little more complicated. So I will go ahead and swap this out to map. So we have, it's going to look really similar in that we just take an array, we use a method called map on the array, and then we pass in a callback function. So the difference here is that there actually will be a return value. This will return a mapped version of the array. So we're going to get a new version of the array out where things are changed a little bit somehow. So really similar in that it's a higher order function called map. It's an array method. It takes in one callback function and it returns a mapped version of the array. So up here, we want to change this a little bit. So this is actually going to return a mapped array item. So let me just clear this out for you guys. Okay, so down here we have our higher order function, which takes in a callback function and returns an array. So the return value down here is an array. Up here, the parameter is just the array item. So whatever individual items are in the array will be coming into this function. And then we want to return a mapped version of the item. So we want to somehow alter this item and then return it. So we can do a lot of the similar stuff that we were seeing with our for each. So let's say that we want to return just the negative version of the array item. So now instead of console logging, which is what we were doing with for each, we actually need to return the item. So I've taken in an item and I'm returning a mapped version of it. And now I run it. And notice that now instead of console logging, we actually have a return value from this. And this is a mapped version of the array. And so this is where things can get kind of confusing, because over here, we're just altering an individual item. Whereas over here, we're actually getting back the array. So there's logic happening behind the scenes that we are not writing. We're only mapping an individual item in our callback, but the map method, kind of out of sight, out of mind, will actually create an entire mapped array for us. So here are two examples of how to use callbacks. So you always need to know, you need some information about the callback. So this up here, I didn't just make this up. This is officially, if you looked up the documentation for map, it would tell you all of this information. It would tell you that it takes in a callback, and that callback takes in one array item and returns a mapped version of the array item, which then on the higher level returns an actual mapped array. So you'll just have to get used to these. I definitely would practice these. They take time for sure. I don't think that there's really anything we do in our day-to-day life that makes you think in this kind of crazy higher level meta way, unless you're just always writing callback functions in your free time, which, I've been there. But yeah, just practice with these. Look at examples and practice, and you'll start to get used to how to use something like map. So let's just do one more map example, and then we'll move on. So now I'm going to do array item minus 100. So the result, even though over here I'm just altering an individual item, the final result of map is going to be an array full of these items with 100 subtracted from them. And there it is. So that is for each in map. We will come back to these actually at the end of the lesson and kind of take a look under the hood. But first of all, I want to show you some simpler examples of how to write higher order functions. So far we have seen how to use higher order functions. We saw for each and map, which are both built-in higher order methods that you can use on arrays. And now but we haven't actually written any higher order functions yet. So that is what we are going to do next. So I'm going to jump over here, and I have written out a couple of callbacks for you. So here are three potential callback functions. And right now they're really actually just regular functions, because they only become callbacks when we actually pass them into another function. So I've created one called greeting, one called sorrow, and one called celebration. And they all just console log different things. And so in the spirit of always asking these input-output questions, first of all, notice that these are all of the same format. In terms of parameters, they have none. Oops. And in terms of return values, they also have none. And just as another reminder, when you have a function without a return value, you can always tell because the value in green is undefined. There's still something that appears over here, which is a console log in white, but the actual function still doesn't return anything. So we have these three functions that we're going to use as callback functions. They each have no parameters and no return values. And we want to create a callback, a higher order function that uses these. So over here, we're going to do a higher order function. I don't know why the formatting isn't working over here, but it's going to drive me nuts. But anyways, okay. So we want to create a higher order function that uses these guys. All right. So, so let's go ahead and create something called, all right, let's go ahead and create our higher order function. So I'm going to call this very specific, I know. So as we know, it only becomes a higher order function if it has an argument that is a callback function. So I'm just going to have that be the only argument. So now we can say that the parameter here is one callback function. And so what we're going to do inside this is I will go ahead and do a console log that just says higher order function example. And then I'm going to execute my callback. So now that remember in this example over here, I was very specific about we never execute our callback. We just pass it in. And that's because it's being executed behind the scenes. But now that we're actually writing our higher order function, it's our responsibility to execute it. So somewhere within our function logic, we actually need to call this callback, or else it would never be called. So that's the call and callback. So over here, we use the parentheses, and we're able to call our callback function. So first, we log this message, and then we call whatever function is passed in. So let's go ahead and see how this guy works. So if I run higher order function, and I pass in, let's say, greeting, notice we get our higher order function example log, and then we get our greeting. If I pass in sorrow, we still get that label, but then we get our sorrow call. So in this way, we're able to really easily toggle through what our second log is by just changing one variable. By just changing which argument we put in, we can change the value of this. And that's really convenient because what often happens in code bases is we might have these list of functions that are used all over the place in the code base. And in this way, we can only have one copy of this logic somewhere in our code base. And then we can still use them by just passing them in, but we don't have to rewrite the console log within our higher order function. So this goes back to this idea of dry programming. We want to make sure that our code is dry. And this type of higher order function logic lets us keep some of our functions separate, but still execute them in some different contexts, like this higher order function. So let's look at another example of this. I want to leave this here, but I will scroll down. So let's create a function called complement. And this is going to take in a name. And then we want to console.log so this function will complement whoever we put in. So if we put in Jesse, oops, let me actually get rid of that. So if we put in Jesse, it will now complement him. So this is we're going to think of this as being our callback function. So it takes in a name, and notice there's still no return value. So I'll go ahead and make a little note of that in the comments. I'll say callback functions, parameters, one string, which is a name, and then return value, none. So in order to use different callback functions with the same higher order function, they always have to be of the same format. So I'll also do an insult. And this has to be exactly the same format, where there's one parameter, a name, and something similar usually happens in the middle, which I will instead console log an insult. And in this way, we have these two parallel callback functions. So these callback functions, when we're using separate callback functions for the same higher order function, they always must have the same format. So we know that for whatever higher order function I'm about to write, that our callbacks always have this format where they take in a name, they log something having to do with the name, and then there's no return value. So let's write a higher order function for this. So I'm going to go ahead and call this thing give feedback. And this function is going to take in a name and a callback. So here's how give feedback will work. We'll call this our higher order function. For the parameters, we see that there are two, a name and a callback function. And then for return value, we're going to have none again, because we're only dealing with console logs right now. So give feedback is going to start out by saying, there's something I need to tell you. Because, you know, if we're going to give someone some intense bit of feedback, whether a compliment or an insult, we probably want a little preamble, right? So we go ahead and we start out by warning them, I'm going to give you some feedback here. And then we want to execute our callback function and pass in the name. So notice that this is going to work with functions of these formats because we know that our callback takes in one parameter and name. So we know that this function or this higher order function will work as long as our callback looks like these guys, in that they take in names. So now we can use our higher order function, give feedback, and if we want to say give some feedback to someone named Amy, we could compliment her. And then it goes, there's something I need to tell you. You're pretty cool, Amy. But if instead we want to insult Amy, we only have to change one line of code. And that's this idea of being dry or being versatile. So now we can totally change what we're telling Amy by just changing this. So we learned about, we saw anonymous functions with our for each example, and notice that we can still do that same thing here. So if we wanted instead to give her some neutral feedback, we could write an anonymous function directly in here and just console log So for our neutral bit of feedback, if we wanted to, we could drop in an anonymous function, or we could put it up here. And with this anonymous function technique versus actually passing in the function name, really the only difference is that we're actually saving it in this case. So if you thought you might have to use the neutral feedback function somewhere else in the code base, you'd want to actually write it out up here. But if you know that the only place this logic is ever going to go is directly in here, then it's fine to write an anonymous function. The final thing I want to illustrate with this example is that is just really driving the point home about the fact that that these have to all be of the same format. So if instead we had something like I'll just call this bad callback example. And let's say this thing is totally different. You know, maybe this thing takes in two names. And perhaps we want it to say console.log Okay. So this function, this bad callback example, takes in two names, and it just says, oh, I like this first person better than the second person. So if we tried putting bad callback example in, things would break. It says, I like Amy better than undefined. And that's because this does not work as one of our callbacks. This thing expects a callback that just takes in one name. And if we alter that and do 2 names instead, then we're going to have a little bit of a breakdown. So that's just a little example of why we have to make sure that when we're swapping out callbacks, all of our callbacks are of the same format. Okay, so that's everything I wanted to show you about kind of a crash course in writing higher order functions. And then I wanted to, before we end tonight, tie everything together by actually going back to this idea of array methods. And we're going to look at what's going on behind the hood with array methods. So as we saw with for each, actually, let me bring back my array. So if I wanted to do array.forEach, I could go ahead and put in an anonymous function. And this is going to take in an item from the array, and we can just, to keep things really simple, console log that item. And when I run this, each item in turn is logged to the console. So as I mentioned before, we just had to write the callback. The higher order function is already written for us. But to understand these array methods a little better, sometimes it's nice to see what's going on. So instead of using the existing for each, I'm going to actually write my own version. So I'm going to create a function called, I'll just call it each. And we'll have this taken an array and a callback. So what's going to happen here is we want to, similar to the for each that's actually built into JavaScript, we want to loop through everything in the array and execute the callback on each thing in the array. So we'll have to use a for loop in here. And we can do our familiar for loop syntax. So behind the scenes within JavaScript's for each, there is a for loop going on. It's just that because that work is already done for us, we don't have to worry about it. So once again, the point of this exercise isn't to show you what to do, because normally you would use just the built-in for each. It's to show you what's going on behind the scenes so you can get a little better idea of how these things that you're learning to use actually work. So we could go ahead and loop through this array, and then for each loop, we might be tempted to be like, oh, console log array at I. But keep in mind that we don't know what our callback is going to be. It could be a console log. It could be something else. So instead of hard coding in console log, we actually just pass the array item into the callback. So we're used to creating a callback that takes in an array item. But here behind the scenes, we actually write out, OK, let's take the array item at index I and pass it into the callback. So now if we want to use our each, we could pass in the array and we could pass in console log. And it runs exactly the same as JavaScript's for each. Or we could pass in an anonymous function, which takes in an array item. And we could do something a little more customized, like console log array item plus 100. So we've actually seen what is going on behind the scenes for JavaScript's for each. OK, I want to do something similar with map. So we saw that there is an array.map method. And as a little reminder, let me get rid of each. Array.map also takes in a callback function. And we're looking at array items in this case. And then instead of console logging or executing some task on it, we actually want to return an altered version of the item. So if we want to do array item times 2, we will create a mapped version of the array, so an augmented version of this array where every item is doubled. So that's how array.map works. Once again, I'm going to create my own version of map so that you guys can see what's going on behind the scenes. So I will call my version map. I'm going to take in an array and, of course, a callback. And once again, we need to loop through the array, right? Because something is happening to every individual item in this array. So I'm going to do my for loop. And now we don't want to just execute the callback, right? On the callback on array at I, because that's what was happening in for each. So the difference between map and for each is that instead of just executing the callback, we actually want to save the result. So over here, we want to, first of all, we need to create some sort of mapped array, right? Because that's the point of map, is creating this new version of the array where things are mapped. So up here, I'll create a new array called mapped array. It's going to start out being empty. And I'm going to go ahead and just write my return statement because we know that map returns this array. So we're creating a mapped array, we're returning it. Now we need some logic in here. So instead of just calling the callback, I want to save the result. So I'll say let result equals the callback of the array at index I. And then I want to actually save that into my mapped array at index I. So what I'm doing is I'm using the callback function to alter each individual item, and then I'm going to save it in the result. And then I save this result in this new array. And so in this way, I can go ahead and call map on my array. And for my callback function, let's do, so we take in an item. Every bracket in the world is appearing here. And then we can just return the item, let's say divided by 2 this time. And notice that it works exactly like JavaScript's map. So you're going to be doing something similar in the homework. So I know I'm kind of rushing through this, and you're welcome to come back to this video. But the point is that this array.map isn't magic. It's actually something not too complicated that we could write ourselves if we wanted to. There's no need to write a map function because it is built in for us. But if we wanted to, we could recreate what the developers of JavaScript were doing. Okay, there's one more thing that I want to show you, and I know we're getting a little tight on time, so we might go a little over tonight just so we can address questions. But bear with me because I want to show you one more array method. And this one is my absolute favorite, but it is also the most confusing. So have some patience with this one. It takes practice to get down. So whereas for each looped through the array and just executed some function on each of these, map actually went through and mapped each item to a whole new array. So for each has no return value, map returns a new array. And now we're going to look at something called array.reduce. So what reduce does is it takes an array and it returns a single value. So let's say that you wanted to take this array and find the max value or sum up the items in the array. You would want to use reduce because reduce takes an array and gives you back a single number. So for reduce, how it works is it takes in a callback function, of course. This callback function is a little more confusing because it has 2 values, something called an accumulator and something called and then just the callback, the array item. So the callback for reduce looks a little different than the one for map and for each. Instead of having just one parameter, it takes in 2, something called an accumulator and an array item. So let's think about this example of summing up all these values. In each case, we would think about the accumulator as being the sum so far, and then the array item as being the item we're at. So if we iterate through, it really is, all these things are looping behind the scenes. So in loop 1, we would have our accumulator just as it will just start as our starting value of 1. And then in loop 2, so when we loop through this array and get to the second item, our accumulator will still be 1, and our array item will be 5. And then when we get to our third step in the loop, we want the accumulator now to be 6, because that's these two added up, and our array item to be 4. And we'll keep going. On the next iteration, we want our sum to be, or our accumulator to be 10, and the item will be 8. So in every case, the accumulator is the sum of everything so far, and the array item is the item that we're currently on. So all we have to do really is tell reduce how we want these two things to interact. So what is happening between loop 1 and loop 2, and loop 2 and loop 3? Well, what's happening in the sum example is we're just taking our accumulator and we're summing it to our current item. So in this way, we can sum these guys up, return them, and they'll become the new accumulator the next time we go through. So we see that we have done it correctly because we have gotten the correct result of 16. So we have taken an array, a collection of items, and reduced it down to a single item, a sum. But reduce is flexible. It doesn't need to be a sum. For example, we could find a max value instead. And in that case, we would just want to say, okay, there is a method called math.max. I don't think I've showed it to you. But all this does is takes two numbers and returns the max value. So we really want to say, okay, what is bigger? The biggest value we've seen so far, or this new value that we're seeing the first time? Whichever of these is bigger, return it. And we see that we've managed to find our max value in this way. So in this maximizing example, we loop through. The first time we're like, well, 1 is the biggest that we've seen so far. And so at this point, our accumulator would be 1. And then we loop through here and we compare our accumulator to the next value. And it's like, well, 5 is bigger. So let's upgrade our accumulator. Then we get to the next item, we compare these two, and we say, okay, 5 is still the biggest. We go to this one, we compare these two, and we're like, okay, we found something even bigger. And then we do it one last time, and we end up with the final value of 8 as our maximum value. All right, well, that was a lot of material for tonight. Thank you for bearing with me. I hope that you're starting to get a little bit of a sense of how to use these callback functions, how to use higher order functions like for each, map, and reduce, and also how to write our own higher order functions if we want. Like, for example, this give feedback function, which logs something every time, but then executes a different callback for different feedback depending on how we want to use it. So those are higher order functions. You have just a couple homework assignments tonight, but don't be surprised if they all take a while, because this is a very advanced topic, and this is really critical. It's really getting into some of what JavaScript truly is and some of the ways that we use it all the time in the real world in web development. But it is advanced. So take the time you need on the homework, and please reach out if you get stuck. And even though it's 6, I will stick around a little late so I can make sure I answer all of your questions. So let me see what we have already in the questions channel, and then feel free to jump in on Slack and ask any other questions that you guys have. Okay, so there is one question that was asked a little earlier that it looks like it's been addressed in Slack, but I think it's a really good question. So I actually want to go ahead and talk about it right now. And so this is a question that was posed by Leanne, and she asked, how does the callback function know that array item is referring to the constant array? So let me bring back this, I think this question could apply to for each or to map. So I'll just use for each. So let me bring this back on screen, and then I'll answer it. So in this case, let's just we'll log the negative version of every array item. So we're looping through this array, and we're going to log the negative version of every item. And so she was curious about, well, how does it know that array item refers to the items in this array specifically. And that's because I've put it on this side of the method call. And so the example I gave might have been slightly confusing because of that extremely generic name. But let me go ahead and say, create a new array, and we'll call this ages. So say this is a collection of all the ages of, you know, everyone in your JavaScript club. So we have someone who's 47, someone who's 24. We've got a 19-year-old, 23-year-old, and someone who's 87. And we're all very impressed that they're learning JavaScript at the ripe old age of 87. So if instead of array.forEach, we did ages.forEach, now array item becomes everything in here. And let's say instead we also had this, this array called names. I'll throw a couple names in here. So I could do names.forEach, and now array item becomes these names. But notice that our logic doesn't really make much sense anymore because we don't really want to take the negative of a name. And in fact, we get not a number because that's what happens when we try to take the negative value of a string. But if instead we did array item and we added an exclamation point on the end, we can still use it with strings. It's just that the logic in here needs to fit with whatever array we're calling it on. So in short, the array item will always refer to the items in whichever array is on the left side of the method call. Okay, I see we have a few. Okay, so we have a follow-up question on that, which is array item is built-in syntax. So this is just a parameter name. So this could be anything. I could call this X. It would still work. I could call this potato, if I can spell potato. Potato. It would still work. I'm not going to call it potato because that's extremely confusing, and this has nothing to do with potato unless, you know, we were using an array of potatoes, which, you know, maybe we are. That's a sweet potato, and a yam is the same thing. Does russet have two T's? I don't know. Not a potato expert. But the point being, and I think that's not how you spell potatoes either. This is what happens when the lesson goes over. I start to yammer about potatoes. Point being, yes, okay, we could call it potato, and that would make sense if we were working with a literal array of potatoes. But usually we just call this item or array item because it's super simple and it makes sense in every case. So it is built in that the logic of for each is built in so that we know that whatever we call this, it'll refer to whatever is in this array. But in terms of the name, that's up to you. You're welcome to use something general like item or array item, or if you want to specify it to whichever array you're actually using, like for example, with names, we could call this thing name. Sometimes it's nice to do that because it's more readable and your fellow programmers or your future self will be really clear about what's going on here. Okay, so Aaron asked about the keyword callback. Yep, so that's very similar. Oh, let me read the question out loud. So he said, do you need to use the keyword callback or is that just the name you choose? Really good question as well. So let's look at this higher order function down here, in which case I've called it callback. So this is actually JavaScript convention that you usually call a callback function callback or CB, which stands for callback. But it's the same thing where it's just an argument. And once again, if we wanted to call this potato, we could and it would work. I don't think there is any situation where we would want to call a callback potato though. So let's not do that. So yeah, once again, this is something that is customizable if you want to make it more specific. But by convention, we usually call it callback or CB. So Sam asked about building a calculator program. and he wants to know, does it use callback functions or not? That is totally up to you. So you wouldn't need callback functions. So to get back to this idea of why do we use callback functions, we love them in web development because they help our browser run really fast. In the case of a calculator, maybe if you're planning on using, doing really advanced calculations, you might want to use callbacks, but you don't have to. So here's a little example. I have some math examples that we ran out of time. So this is kind of perfect. So I will bust these out and do a little example. So for example, if you wanted to increment, triple, or half a number, let's say you wanted to create something that we'll call this add to, then triple. So this is a function, and what it's going to do is take in a number, and it will return that number plus 2 times 3. All right, so here, this thing totally works. So if I put in a 4, we see that we've added 2, and then we've added 2, so we get up to 6, and then we times 3, and we get 18. So this is not a higher order function. It only takes in a number. This is just a regular run-of-the-mill function. But this is kind of specific, right? How often do we want to specifically add 2 then triple? So what we could do instead is we could do something called add 2 then. And that means we want to add 2 and then do something else afterwards. So now we could do, let me break this down a minute, something like added 2, which is number plus 2. And then we can return the callback. Oh, I capitalized it. I didn't mean to. Callback of added. So what this function does, and this is a higher order function because it takes in a callback, is it's going to add 2 to a number and then it'll execute some other operation. So we could do add 2 then triple by putting in the triple function. We could also add 2 and then cut it in half using the half function. We could add 2 and then add 1 more by using increment, So I will admit that to me, this is a very convoluted way of doing something kind of simple. So if I personally were writing a calculator app, I probably wouldn't bother with much higher order functions or callbacks because you don't need them. But if you wanted to, and if you wanted to get some practice with this, you certainly could. So here's a little example of how that might work. All right, anyone else? Okay, I think we will call it then. And to respond to your comment, Erin, I'm happy to spend some extra time today. I think this is a super fun, interesting topic. So I'm glad that we were able to take the time we needed. And thank you guys for sticking around a little later to ask your questions. So, okay, I think that we are good to go on this topic. Well, thank you for sticking with me tonight, especially since it was a little bit longer of a lesson. Once again, we're getting into some really crazy mind-melty topics in JavaScript. So I personally think that these are the topics that make programming really exciting, but I also know they can be the topics that make programming really scary at first. So don't get intimidated if it doesn't make sense at first. It really wasn't until about 6 months on the job that I started feeling really comfortable with these things. But once you get comfortable with them, they are such powerful tools. So that is all for tonight. Tomorrow we're going to talk about closure, which is another really critical topic in JavaScript. So I will see you guys all then, and have a great night. All right, bye guys.